4.5, graphing other trig functions. So previous section you learned about sine and cosine. This section is about tangent, cotangent, secant, and cosecant. We'll start with tangent and cotangent first. Go ahead and pause the video, and I would recommend jotting down this whole table right here into your guided notes. One thing to note, anytime you see n, that's for any integer. Okay? I didn't want to throw in the fancy symbols, but it's for any integer n. So domain for tangent is all reals except for when x is equal to pi over 2 plus pi n. What does that mean? So if n's equal, so at n equal to 1, for example, 3 pi over 2, tangent does not exist. Okay. And then at 0, tangent does not exist at pi over 2, and so on and so forth. That's the same that applies anytime you see the letter head. Also, last couple boxes. These go on forever. Okay. Whenever you look at the graph, it will be apparent what I mean by that. But there is no set end behavior to these. Yeah. And then symmetry is the origin. There's no extrema. Okay. If you think about it, remember tangent, sine over cosine, and cotangent's cosine over sine. These fractions can get, like, of course, sine and cosine can both be 1, but let's say that sine and cosine can be 0.99, right? If the one is 0.99, that means the other value could potentially be 0.00 something, right? Which is going to get you a really big number. So that goes on forever, okay? So that's why we don't have extreme. There's no minimum, no maximum, because it can be very, very negative, it can be very, very positive. And there are asymptotes with these graphs too, because as you know, for tangent, any value that makes cosine 0 makes tangent not exist because you can't divide by 0 because tangent sine over cosine or y over x. So if tangent's y over x, any value that makes x equal to 0 will not exist, which is why you have asymptotes at pi over 2, right? Because x is equal to 0 at pi over 2. Here's what the graphs basically look like. I'm not the best drawer with my finger on my laptop here, but here we go. What I recommend you do also, if you can, is match these up with the chart you just wrote out. That might help you a little bit in seeing, oh, look at the intercepts for tangent. They're at 0, pi, 2 pi, negative 2 pi. Then you look at the asymptotes, since pi over 2 and 3 pi over 2, etc., is not on your graph, you put little asymptotes at those values and draw them somewhere between, for example, pi over 3 and 2 pi over 3. And notice that the tangent graphs start down and go up, as opposed to cotangent graphs that start up and go down. Same thing with the intercepts. Intercepts are at pi over 2, 3 pi over 2, and then you have asymptotes at 0, pi, 2 pi, etc., etc. Time to do a few examples involving cotangent, tangent. I got two with tangent first. So a tangent of x over 2. So a little tip, since your b value is 1/2, because 1/2 times x is x over 2. Take all your original asymptotes, divide them by pi over 2. So not pi over 2 over 1/2. I was about to say, do pi over 2 divided by 1/2. 3 pi over 2 divided by 1/2. What's that going to get you? So pi over 2 divided by 1/2 is going to be simply pi. We're going to have asymptote of pi, asymptote it. And then the next one is 3 pi over 2 divided by 1/2. It's going to be 3 pi. Look at that. Yeah. And then negative pi and negative 3 pi. So if I ask you what the period is, period for tangent and cotangent and secant and cosecant is always pi divided by the absolute value of b. Your b value is 1/2, so your period is 2 pi. So look, your period for tangent, cotangent is always going to be what's in between your asymptotes right here, right? So nothing else changed. So I still have that. Have intercepts at 0, 2 pi, negative 2 pi. And then it's going to do one of these. That was poorly drawn. And they never touch the intercepts, but they get very, very close to them as they approach infinity. And this one, what do we notice here? So we notice a shift to the right by pi over 4. And we also notice this right here. Now, what's that do to the graph? Anytime you see a negative in front, what it's going to do is it's going to flip the shape of the graph. It's going to do one of these instead. It's going to look like a cotangent graph almost, except, well, I guess not except, but just only in regards to the shape of each of the individual line. So all of our asymptotes going to be going over pi over 4. So we have new asymptotes here. Move to the right, pi over 4. We're going to go there and here. And we're going to go right here. And get the point from there. All your intercepts too, you're also moving all your intercepts over pi over 4 to the right. So the original intercept was at 0, now you're at pi over 4. Looking like that. And then around there as well. Cool, cool. And then also pi over 4, so around there. So all your intercepts just go to the right pi over 4-ish. Right? Now this one's going to be a little tricky to draw due to the graph, and just follow along here. So your period, remember I said pi divided by b, so your period's going to be pi over 3. Okay? In terms of this graph here, it's not giving us a ton of space. So what we're going to do, take all your periods and divide them all by 3. If I already give you this on an assessment, you'll have a graph that has more space so you can draw a little better than what I'm going to be able to draw here. So every pi over 3, you're getting an asymptote. Okay? And since cotangent, you start at 0. Okay? And all your intercepts are going to be halfway in between. So at 5 pi over 6, that's going to be 1/2 pi. Pi over 6, and then that's going to be a tight squeeze here. I'm also a little crooked, so apologies. So, like that. You got the cosecant and secant function. Pause this whenever you get a chance to jot this information down. A few points of emphasis. Same story as before. So cosecant, remember, is the reciprocal of sine. So anytime sine is 0, it won't exist. Sine is 0 at 0. So cosecant is not going to exist there. You're going to have an asymptote there, actually. And so on and so forth. At pi, 2 pi, and secant is similar, but at pi over 2, 3 pi over 2, etc., etc. The range might throw you off, but think of it this way. So remember, sine and cosine cannot be more than 1, and it can't be less than -1. So it's always going to be less than negative 1 and 1, it's always going to be 0 point something. So if you're doing 1 divided by 0 point something, it's going to be more than 1, or it's going to be less than negative 1. So the range can never be between negative 1 and 1. But it can't include that because 1 divided by 1 is 1. Negative 1 divided by 1 is negative 1. I'll scroll down here so you can get this last part here. Same sort of the asymptotes. No extrema because they go on forever. They're fractions that have 1 over 0 points, whatever, right? That can get bigger and bigger or more and more negative, depending on which way you're going. Here's what the basic graphs look like. Once again, I recommend you have the chart right beside here so you can look at them side by side for it to make sense. Also, the friendly reminder, these are referencing your unit circle, right? So it's 1 over, in the secant's case, your x values. And I just realized these are backwards. Sorry, cross it out. It's y equals secant x, y equals cosecant x. Okay, because it's the graph on the left is the reciprocal of all your y values. And this one's your x values in regards to your unit circle. We're going to do 2 examples and we'll call it. So first we have cosecant of 2x. So that means our period is pi over 2. It's always going to be whatever the b value is on the denominator and you're dividing. It's pi if needed. In this case, it's just pi over 2. So what does that mean? If we look at your cosecant graph, all your asymptotes will be half of what they originally were. So instead of it being at pi, it will be, I'm going to zoom in and make this try to improve how it'll end up looking. So it being at pi, it'll be pi over 2. Instead of at 2 pi, it will be at pi. Instead of at negative pi, it will be at negative pi over 2. And then instead of it being at 3 pi, it will be at 3 pi over 2. So we'll get this going a little bit. Oh yeah, and of course, still dividing 0 by 2 is still going to be 0. So, that's going to cut our x value in half for when it's first at 1. Instead of it being at pi over 2, it will be at pi over 4. And I'm going to use a different color to make it stand out. And then down here. And then over here. All the original x values, just divide them by 2. And there's a couple periods of your graph. And then we got y equals secant x plus pi. So that means your whole graph, you're moving to the left pi, which is just going to make your asymptotes the same area. You're still going to be at negative pi over 2, pi over 2, 3 pi over 2, negative 3 pi over 2, and the tricky part really is that where they're facing up or facing down is what's going to be flipped since they're moving over pi. So instead of it being up at 0, 1, it will be down here. It will be up here, and then it will be down here, because all the values are moved over to the left pi. Oh wait, not down there, up here. Alright, appreciate you watching, and I'll see you in class. Bye bye now.